Welcome to Google Cloud's digital conference, Better Code Faster. I'm Dan Lawrence at Google Cloud. I'm going to be talking about CI/CD pipelines to build, test, and deploy to Kubernetes locally today. We have Googlers on standby to answer your questions live, so please click on the icon to your left and ask away. I've been working in the platform as a service and container space at Google for about 6 years now, but recently I've been focused on improving the Kubernetes developer experience. I founded and maintained the Minikube project and led the team that built Canico, Container Diff, managed base images, and Skaffold, which we'll chat about a lot more today. I'm really excited to be here with my colleague Kim Lewandowski.
Thanks, Dan. Hi, everyone. I'm a product manager at Google. I've been at Google for almost 5 years now, working on a number of GCP products, including Cloud Task, Cloud Scheduler, and App Engine. A year ago, I joined Dan's team to help engineers get their code deployed to Kubernetes. Kubernetes and I were meant to be together since there's a K in my name. Skaffold is one of the many tools we've created. It automates Kubernetes development, makes it fast as possible, and hopefully makes it fun developing code for Kubernetes. So today we're going to be discussing how Google is making Kubernetes easier to use and developed. Google started the Kubernetes project several years ago, and the growth has been amazing to watch. Kubernetes today is a lot easier than it used to be back in the pre-1.0 days, but there's still a lot of work to do. We'll explain a few different areas Google Cloud is investing in to help improve developer productivity and experience. Then for the rest of the session, we'll do a deep dive on Skaffold, an open source tool designed to automate and optimize the inner development loop for Kubernetes. We'll explain why this inner loop, edit, save, refresh is so important to engineering productivity and business success.
Let's get started with a quick discussion of some of the different ways companies are adopting Kubernetes and making it easier for their developers to use. So Kubernetes is a really interesting platform because it has many of the features you'd expect from a modern platform as a service product included, but it tends to require more work to configure and use them than these other platform as a service products. I like to think of Kubernetes as a PaaS platform rather than a PaaS product itself. This can lead to a lot of confusion though. In the community, some users are left guessing as to whether they should be looking at Kubernetes itself or one of the many platforms built on top of it. Within the Kubernetes ecosystem, we also spend a lot of time discussing whether certain improvements should be made inside of Kubernetes or left to third-party tools or extensions in the community. If serverless platforms provide a batteries included experience, then Kubernetes provides a batteries included but not installed yet, and you can replace or swap them out for any other power source you want to.
So developer experience is a topic I'm really passionate about. Here at Google, we believe it's clear that a great developer experience really is key to adoption. We have a number of ongoing efforts at Google to making development for Kubernetes easier. We have teams building higher level abstractions on top of Kubernetes, so all you need to do is hand us some code and we take care of the rest. We have open source building blocks in a project called Knative, so anyone can take these and build their own serverless-esque products on top. But we also need to make developing apps for Kubernetes directly more enjoyable and fun. And we're working on that too. There's a lot of low-hanging fruit that we're iterating on and improving each day. For example, let's see what a developer has to go through when building and iterating on a simple app today. There are a ton of concepts you have to understand, configure, and work with to get a basic development loop running for Kubernetes. First, you need a cluster. This is usually either something running locally like Minikube or a GKE cluster used for development. Then you need to get your application into a container image and find a place to store those. And then you need to write some YAML files so Kubernetes knows how to run your images. And only then can you see your code running. To make minor change to your app, you have to repeat all of these steps. This is pretty complicated to try to explain, so let's look through a real example. So let's see a demo of a pretty basic sample application. This is a Golang emoji web server, very important. It starts with a bunny emoji and increments it each time you get an HTTP request. It gets built with this Docker file here. So this is a multi-stage Docker file that builds in one image and copies the binary to another one. This is good best practice to keep your images small. If we want to get this running in Kubernetes, first we have to build the Docker image using Docker build. Then we can give this image a unique name using the Docker tag command. And push it to a registry. Next, we can take the image and stick it in our Kubernetes YAML file and apply that to our cluster. And then we need to set up the load balancer. Finally, we can see our running application. So let's say we want to change our message to something a little different than hello app dev. We make the edit to our code and then go through the same set of steps again. Docker tag, grab the new hash. Update the version. Push to our registry. Then apply. Set up port forward. Cool, so that worked. So now you just saw how we can develop a basic application for Kubernetes.
As you can see, this work gets pretty repetitive fast. There are a lot of layers in between your code and your text editor or your IDE and your app running somewhere you can see it. Most of the noise here is around things developers don't even really care about. Thankfully, as developers, we usually have the tools we need to automate some of this toil away. Laziness is a programming virtue.
Yeah, some of the best programmers I know are always the laziest ones because they automate everything and don't want to waste time on monotonous tasks.
This applies outside of programming as well. My background is actually in mechanical engineering. I've been getting back into wood and metalworking in my garage. All of the best people there follow similar practices. Whenever there's a specific cut you have to make or a specific hole you need to drill a bunch of times, you build what's called a jig, a small purpose-built tool to help with a specific task. By investing some time up front, you can improve your productivity later. Unfortunately, this leaves the same set of core problems for every developer to solve on their own, which can lead to even more problems.
So in larger teams and companies, you can see how these problems can snowball and make for an unproductive work environment. New engineers have a really tough time getting started, and no way are they pushing code on their first day on the job. I've worked at companies where each team had their own bespoke way of delivering software. It was a mess, and our DevOps engineers were pretty grumpy.
It would be pretty straightforward to replace a bunch of the commands we just went through with a bash script or a makefile, but that's just moving your problem around. These are very hard to get right, tend to be copy and pasted across projects, and add to the maintenance cost. I had several of these floating around for every Kubernetes project I was working on, and most of my colleagues did too. This problem is why we decided to build Skaffold. So there are a bunch of different possible workflows for building container images, templating your YAML files, and deploying to Kubernetes. We only went through one of them before. But we think we can cover most of these with a single tool that exposes a few options. Skaffold makes it easy to focus on the parts of development you really care about, your code and running application, by automating the rest of the development loop away.
So Skaffold is an open source command line tool that automates and optimizes Kubernetes development. It eliminates all of the things we don't want to care about and shouldn't have to care about. It handles all of the things we wish would just happen in the background. Skaffold monitors for changes, rebuilds and containerizes your code, updates Kubernetes configuration, and redeploys your application whenever necessary, all under one command, Skaffold dev. This makes it easier for new team members to get up and running with a few commands by automatically optimizing your dev loop. And now we're going to see a demo of our basic application again, but using Skaffold this time. So instead of writing a bash script or executing the same set of commands each time, we first have to write a scaffold.yaml file. This is a file that specifies what images you need to build, how they should be built, and then how they should be deployed to Kubernetes. Rather than telling Skaffold the exact set of steps to execute in order, like you would be doing in a bash script, this file is declarative. You're telling Skaffold what you want to happen. Like I have 3 images that build using Docker, and I deploy them using Helm. Then Skaffold can use that information to optimize the build and deploy process as much as possible. These files are also designed to be portable. There's nothing in here about my exact cluster or GitHub repo. Someone on my team can write this once and share it with everyone else. A lot of popular open source projects already have a scaffold.yaml file inside them. Next, we set up our development loop with the Skaffold dev command. So this builds all of our images and gets us running in a Kubernetes cluster, then waits for us to make changes to our source code. So we can see the message here from before, hello world. And refresh, we get different emojis each time. So next, if we make a change and save our file, So we can see that Skaffold automatically detected it, rebuilt the application, and deployed it to Kubernetes. Give it a second here. And refresh, and there's our change. So we didn't need to know anything about Docker, kubectl, or YAML files. So cool, you just saw a demo of using Skaffold for a basic Kubernetes application.
And now we're going to look at a demo of some of the more advanced Skaffold features. The examples we showed before are pretty basic, just a single service, a single Docker file, and a single Kubernetes YAML. This example is going to be a little bit more realistic. It's going to have a couple different microservices we're going to be developing on at the same time. This application here has two microservices, a Golang backend that encrypts HTTP requests, and a Flask front end that displays an interface to that. We can develop this app with a pretty similar scaffold.yaml to the one we used before, except now you see we have a couple different container images listed inside of here that we're going to be building. Skaffold builds an automatic graph of which container images here are used by which Kubernetes service, so it knows which source files are used by each one of these. We set up our loop with Skaffold dev again. We can see that in parallel, it's going to build both of these container images and deploy them to our cluster. Like before, it's going to automatically set up port forwarding for each of these services to our laptops, so we don't have to poke any holes inside of our load balancer to access and debug these services. The Python Flask front end is listening on port 5000, so we can take a look at that in our browser. So this is our awesome front end to our encryption service. We can type in a message we want to encrypt and submit. Well, we can see the highly secure encryption algorithm returned to this as our output. If we wanted to debug the backend service directly, that can be difficult if it's not exposed outside of our Kubernetes cluster. Thankfully, Skaffold port forwards this as well, and it's listening on port 8080. We can send a message directly to that and see that it's encrypted. It's pretty easy to see what's happening here. Instead of encrypting, we're actually just reversing strings. So if we want to do some debugging and fix that code, we can come to our encryption service. And here's the problem. Our encryption function is just reversing a string. Thankfully, we do have a really encrypt one defined below down here that we can switch the implementation out to use instead. Now, once I hit save, Skaffold detects that only the backend service has changed, so it leaves the front-end service running while the backend service gets rebuilt and redeployed. This is a way to speed up the development loop by only deploying what needs to be deployed. Another great feature of Skaffold is the automatic log streaming here. When you deal with a large-scale microservices application with multiple instances of each microservice running, it can be hard to get sensible output from the logs. But Skaffold intelligently streams the correct logs for each deployment and logs them with the correct colors down here, so you can see, you can easily see which service is logging which. If we jump back to our browser, we can see the new encryption service, and that looks a lot more secure than before.
Thanks, Kim and Dan, for introducing Skaffold to us and showing how to use Skaffold with basic applications. In this demo, I want to show how to deploy complex microservices with Skaffold. My name is Ahmet Alpbalkan, and I'm a software engineer at Google. So you've tried Skaffold with some basic applications, and you joined a new team, which is a lot of microservices. This is typical. A lot of companies have a lot of microservices, and this is what's empowering their business. So let's see if we can use Skaffold to deploy a complex application on your machine, deploy it to a local test cluster, and then build images on cloud with Docker, and then run it on a Google Kubernetes Engine cluster. So the demo application we'll be talking about today is a demo called Hipster Shop. You can try Hipster Shop on your own by downloading it from this link on GitHub. Hipster Shop is a web application. It is like an e-commerce app that has a lot of microservices serving your requests. Hipster Shop has 10 different microservices written in languages like Go, Java, Python, and Node. And Hipster Shop uses Skaffold to deploy the whole application. In this case, we're seeing a service graph that is consisting of multiple microservices. So the traffic comes from the internet to the front end, and then from there it goes to services like the ad service, the cart service, and then the product catalog and the currency service. So these services are calling each other to serve your requests. So let's see how we run this application on Skaffold. Here, I have a Skaffold YAML file that is deploying the entire application. In this configuration file, I'm seeing a list of images and how the images are built. In this case, I'm seeing a set of 10 microservices that are built from source and then deployed to a local Kubernetes cluster. So if I go back to my terminal, if I run kubectx, I'm going to be choosing Docker for Desktop as that is my local development cluster. So this has a Kubernetes cluster installed in it, and then if I run Skaffold dev here, I'll be building and running these applications in a local cluster environment. Skaffold dev gives me an opportunity to iterate on my code and redeploy and rebuild these applications and even redeploy the changed configuration files as I edit through my files. So after this build finishes, you're going to see that all the services that are configured in the application are built, and then they're running on the Kubernetes cluster. So now, let's see if we can go to the Google Cloud with Skaffold. What I'm going to do here is first, I'm going to point my kube control to a GKE cluster on the cloud. And then I'm going to specify Google Container Registry to push the microservice images. These microservices are going to be stored on GCR, and then when I create a cluster, they will be pulled down from GCR to run them. So different than the Skaffold dev command, the Skaffold run command gives me an opportunity to deploy these microservices in a single one-shot way. So when I run Skaffold run, everything will be built once and deployed once. If you want to redeploy, you will need to run Skaffold run command again. So let's switch back to my terminal. And I'm going to use the kubectx command to switch to another cluster running on GKE. In this case, if I run kubectl get pods, you're going to see that none of the pods are running. So now, let's do Skaffold run, but we'll be providing an argument called --default repo specifying the microservices I have in this cluster. When I run this command, similar to Skaffold dev, all the microservices are going to be built and pushed to the Google Container Registry this time, one after another. So if I go back after deploying this image, you're going to see that if I run kubectl get pods again, my services are going to be running here. So now let's go back and try to use this application. As you see, visiting the web front end for the application image gives me this nice storefront. So as I click through these product pages, they're going to be served from different services. And then if I change things like the quantity or add items to the cart, you're going to see that they're still being served correctly by Skaffold. So this is how you use Skaffold to go from your laptop to Google Kubernetes Engine clusters. So far, we've been building these container applications on our local Docker and then pushing it to Google Container Registry. However, Skaffold can build things in the cloud as well. So we have this product called Google Cloud Build. It's like Docker Build, but it's on the cloud. To push images to Google Container Registry, you've been doing Docker Build and then Docker Push by using a local Docker engine. However, with the gcloud build submit command, you can upload your source code to the cloud and have Google Cloud build your code and then push it to Google Container Registry. So Skaffold supports Google Cloud Build. And you can build and push images to Google Cloud Registry without having to install Docker on your machine. So this is all we have for the demo. Thank you so much. And we're going to give it back to Kim to talk about how Skaffold improves developer productivity.
So as a product manager, I care about shipping things to our users as quickly as possible. I don't get to tell the engineers to work faster. So when I learned about how much time engineers waste while waiting for builds, I got passionate about working on products that make that time as short as possible. Here at Google, we routinely conduct studies on engineering productivity. And recently, we learned that if an engineer doesn't come back to code from a build after a minute, we've lost them for over 30 minutes. This may explain all the high scores I notice in our game room. I think the car racing game is particularly popular. The more time engineers get to spend writing code and the faster they can ship that code out the door means everyone wins.
That's definitely true for me myself. I have a very low attention span, and I tend to go on Hacker News or Reddit every single time my build takes a while.
So in addition to automating this inner loop and making it easy as possible to get started developing on a new project, we've also tried to optimize this loop as much as possible.
We all know that famous "my code is compiling" comic from XKCD, and it's as true today as it has ever been. Fast builds are important to keep developers productive, on track, and in the zone. And we've done some really cool work in Skaffold to optimize this loop to keep you off of the internet. One of my favorite ways to make something faster as an engineer is just to do less work. This ties back into the laziness principle from before. It's actually really hard to make something faster, but it's pretty easy to figure out if you can just skip doing something altogether. Who cares about how long a build takes if you don't need to do it in the first place? This is one of the coolest features of Skaffold. It looks like automatic dependency detection. Skaffold intelligently parses your Docker files and builds a multi-level dependency graph from your actual source code files to running services inside of a Kubernetes cluster. This means that Skaffold knows exactly what needs to be rebuilt and redeployed depending on what has changed in your application. If you make a change to a configuration file used only by your front-end service, Skaffold realizes that automatically and doesn't need to rebuild or redeploy your back-end services. When you do change a shared file, Skaffold can make sure you're always running the most recent code by rebuilding everything that it needs to. Let's take a look at that in action using our microservices example from before. And now we'll show a demo of how Skaffold can optimize your development loop even further. In the previous demo, we showed how Skaffold can detect which files have been changed and use that knowledge to rebuild only the services that need to be redeployed. But Skaffold can optimize things even further than that. If we take a look at our Python Flask front end, it's a simple main.py file here that renders a couple templates. If you make a change to one of these template files here, which are just HTML, Skaffold can tell that these don't actually need to be rebuilt into a Docker image. Even though we're using advanced Docker caching features, those builds and pushes still take time. And if we're changing an HTML file here, all that has to happen is we have to upload just this one file. So let's take a look at how Skaffold can do that even faster. If we want to change the HTML to be something different than welcome to the encryptor, we can say, and hit save. So Skaffold, instead of rebuilding a container image in this case, just syncs that one file directly into our running container. So that build happened in under a second. We can see that running inside of our cluster here. So you just saw a demo of how Skaffold can optimize the development loop with file syncing.
So Skaffold also has a pluggable architecture that lets you choose the tools in the developer workflow that work best for you. You can choose different build configurations, builders, and deployment tools, whatever you're using today. For example, Skaffold works with Jib, Google Cloud Builder for remote builds, and Canago for doing builds directly in your Kubernetes cluster. It also supports popular deployment methods besides using kube controls such as Helm and Kustomize with a K. So one quick plug for Jib. For those not familiar with Jib, Jib is another open source tool from Google that gives Java developers the power and flexibility of a Docker container with none of the setup and necessary knowledge of Docker. So if you're iterating on your code locally at a high-powered laptop running Docker, you might use this flow where you can make use of a local cache for fast iteration.
Or if you're using a Chromebook, or maybe even running inside of a CI environment where Docker is hard to run, you can swap out a few lines in your Skaffold YAML to use Google Cloud Build instead of requiring a complex, powerful local setup. You could also use Helm or something like that for a more powerful package manager.
So to wrap up today, we've covered how important developer productivity is to a company's bottom line. We showed how Skaffold can be used to help automate and optimize Kubernetes development. And try it out and let us know what you think.
Thank you for joining us today. Please stay tuned for the next session, Architecting for Continuous Integration and Delivery on Google Cloud. We hope you enjoy the conference.
Well, that was a great session, Mark.
Absolutely.
The serverless sessions will actually be going over the same demo throughout all 4 sessions. So please make sure that you learn and remember and retain what you're going, because you're going to be building upon those previous sessions over the course of these 4 sessions.
Exactly, right? It's a great use case to show like how one demo, you're actually kind of breaking up an application in all these individual pieces, and then some pieces can go serverless, and then depending on your application structure, not everything has to be on serverless. serverless.
Right.
But you have this flexibility, right? And this kind of plays into this idea of monolithic applications versus microservices, right? With a monolithic application, you might have everything kind of contained in one area, and you're using all of this extra management to maintain the infrastructure, but you're not really taking advantage of that. So when you break things out into microservices, you have a lot more flexibility, and serverless goes hand in hand with that, right?
Like portable and flexible as well.
Exactly.
Yeah.
You add on the ability to move it around. You add on the ability to kind of independently scale and structure each one to be really clean. And that gives you more focus on the actual code instead of, again, managing infrastructure that you're not really taking advantage of. So we really recommend looking at how that can be flexible, but also how that can be applied to any use case.
Right, right. So with an overview of Kubernetes and Skaffold, I would like to welcome back the viewers from the CI/CD track, and we can see how we can make sure the code moves faster with this Kubernetes and Skaffold paradigm. And so what does this have to do, or what does this have to do with serverless in general?
I think in the same way, right? It fits in with this concept of having the options for whatever your use case is. So for those who didn't get a chance to check out the CI/CD talk, it looks at Skaffold, which is a way to move containers kind of through a build pipeline, essentially. But what you're able to do is take containers and deploy them a lot easier. Now, this helps speed up people who are using Kubernetes. This helps speed up their process to actually make the code changes, but then to actually put it into testing and maybe even production. And it gives this idea of, again, what's right for your use case. So by taking the containers from kind of your local code and pushing them out there, it's the same paradigm that serverless has, right? You're able to focus on the application code and go through a lot quicker process to get it into production. This means, some of the old kind of ways of doing things might be like more of a hierarchy or more of an approval chain that doesn't really add any value. It just slows things down.
This goes back to Abby's talk.
Exactly, right? The idea here is that DevOps as a whole is more of a cultural shift than it is kind of just a switch that you can flip. It's just not that easy, right?
Yeah.
What you really want to do is focus on how do we take this idea, this methodology, and put it up to our entire organization, and why that really adds value, and more importantly, speed. Right, because this is going to see better results with a lot less kind of stuff to jump all the works.
Right, right.
Yeah.
And when we go into, along the same lines, we've been talking about serverless and CI/CD.
Absolutely.
We are going to talk in the next session about serverless and machine learning. And Sarah Robinson always does a great job. You're going to have the opportunity to hear her in this next session, where she's going to walk us through how to define your machine learning strategy depending on some of the choices. And when you make those, when you are working on a machine learning project, one of the biggest things that you need to think about first is the amount of data you have.
Right.
And the choices that you make depend on the amount of data you have. So before you start, the best practice is to always check the machine learning APIs available and whether those APIs are going to fit the use case that you're trying to work on.
Right. Again, it's like breaking out these different services in terms of what makes the most sense.
Exactly. And then if you find out that that does not fit your use case, that's when you start to look at cloud ML, where auto ML, which is where you start to see that here are all the images, or as an example, right, here are all my product images that I would like a custom machine learning model for. So I would use the pre-built model and augment it with these custom images that I have for my products, and then use the auto ML engine to kind of combine the two together and build my model. And then if that doesn't fit the use case, then that's when you start to look at building your own models from scratch. And we have tools for that in terms with like cloud ML and also TensorFlow that you will utilize to scale and build the models at scale in a distributed fashion. But again, it boils down to defining how much amount of data you have and then making the decision to choose the right strategy for machine learning.
Absolutely. So we've got some great content in both the serverless and the CI/CD sections, so stay tuned for those, and we'll see you soon.